Today's video is a bit about some chores I've been meaning to do. So today I'm going to go over how I designed some feet that are going to connect to these bottom clasps here and hopefully keep it a little bit more upright. And also just a bit about my workflow and how I get designs I make in Blender all the way to my 3D printer and out into reality. So the first step, as always, is going to be a quick sketch on some actual paper. So in our case, we've got a screen very roughly like this. And it's got a couple little eyelets along the bottom that we want to attach to. So what I was thinking, if you look at the screen from the side, like this, I was thinking very simply a couple of kind of a wedge shape that goes back like that on either side, just two copies, and has a little slot here for this to fit into. And so we're basically going to try and just make a very simple polygon in Blender that matches the dimensions we need. And then we're going to cut a little notch out right here that we can just slide those little connectors into, and then everything will be fine. So in our sketch, we decided to do basically a really simple wedge to hold the screen up and keep it from tipping over. And so I'm just going to start by adding a plane. We're just going to keep that at 2 centimeters now. And to make it a triangle, I'm just going to grab these two at the top and merge them at the center. And now we have a triangle. One thing I like to do when designing for 3D printing using Blender is keep my shapes two-dimensional if possible, and then use modifiers to make them three-dimensional. And I'll go in a bit more detail about what that means exactly, but for now I'm just going to make a really simple triangle that's about the wedge shape I want. I think I want it to be a little bit shorter than that. So locking to the Y, drag it down, and drag it down a little more. There we go. So our board itself is about 2.2 millimeters thick. As we measured, it was a little over 8 millimeters wide. And so we're going to make our legs, for starters, an even 1 centimeter wide. And in fact, let's move all of these up so that our baseline is right at the bottom here. And also, we can rotate it along the X by 90 degrees and move it to dead center. I'm just gonna kind of doing a little cleanup here. Just want everything to be on even ground here. So now we have this 2D triangle that is going to kind of hold our display. And I'm going to want to change how thick it is in the future and a few other things, but I don't want to have to manage all of those vertices manually as I go through and make different decisions. So I'm going to go over here to the modifiers panel, which is this little wrench here. And this sort of lets you do make changes to the geometry that aren't permanent. But we're going to use the solidify modifier. And you can see that what that does is makes this, extrudes this shape basically along the y-axis to make it a certain thickness. And we're going to say even thickness and high quality, and we can see that it already has defaulted to a centimeter. And then later, if we decide a centimeter is too thick or too thin, we can just change this and no matter what we've done to our geometry as far as the shape of our object goes, we're going to be able to adjust that pretty easily. So that's actually pretty good for a small base. It's 2 centimeters long by 1 centimeter wide, which is probably, looking at the screen, not going to be quite big enough. But for starters, we're going to use another modifier now, and we're going to basically put a little slot into this object that our screen's going to snap into, and that's going to give us a bit more of a sense of the scale of this scene. So to do that, we're going to want this to be around here, so we'll just move our cursor there, and then we're just going to make a cube for starters. And now here we're going to adjust the dimensions to be roughly the size of the small tab that is at the bottom of the display module. And so we measured that earlier, and it's going to be, let's see here, if our object is like this, and in fact we're going to rotate all of this along the Z by 90 so that our screens match up. So this is the front, and that is the front. So we want this to be, our measured width was 8.2 millimeters wide, so let's match that exactly. The X is going to be 8.2 millimeters wide. The Y, the thickness of it is 2.2 millimeters, so we're going to do that as well, 2.2 millimeters, which you can now see there. And then the Z doesn't really matter because we are going to be just using this as a Boolean operator, and I'll show you what that means as well. So we're going to move this over here along the X so that it's dead center in our foot, and then we're going to move it along the Z so that it comes down the right amount. And that's one measurement I forgot, but I can do it real quickly. Our tabs are about as tall as they are wide, about 8 millimeters deep. And so we want this to come down 8 millimeters from the top. So the easiest way to do that is just to make it 8 millimeters tall. And now we know the depth in real-world units of what we want. And so we can already see that if our tab is going to be 8 millimeters deep, this is going to be too shallow to hold enough of it to really give us a lot of stability. So we're going to go back into our geometry and we're going to change this. And in fact, I think the way I'm going to do it is put our cursor to the center here, switch over to, let's see, the dot, to 3D cursor scaling mode. So basically now all of my scaling will be relative to this center point. And I'm just going to scale this up so that we have enough depth in our volume to contain the tab that we want to cut out. So that looks a lot better, and we can even move this up a little bit to about there. So now in 3D we have this. Remember that the geometry itself is just this flat triangle. And now as I look at it, it really should have a bit more width to it as well. I don't think that just having this 1 millimeter or so on either side is going to provide enough support. And so I'm just going to make this 1.5 centimeters wide. How about that? And then I can move this over to be roughly in the center. Doesn't have to be perfect. Or if it does, you can spend the time, but I will not. Also, let's do something I always forget to do. We're going to name our objects here. So this is going to be foot. And this is going to be tab cutout. And now you'll see a little bit more modifier magic. So you can add multiple modifiers, and then they get basically applied to your object in a particular order. So in this case, we just have one, so it doesn't really matter. But now we're going to add another one called a Boolean modifier. So we have a Boolean modifier here, and basically what this allows you to do is to use another object as a knife to cut a shape out of yours, of the object you're applying the modifier to. And so in this case, if we use a difference modifier and then we just hide this, you'll see that we have a nice slot cut out of our extruded mesh for us without having to manage any of that geometry. So still, the only geometry we have are these 3 points, a single triangle, and using modifiers, we've created this 3D object with a slot cut out of it that we can pretty easily modify. If we decide we wanted it to be shallower, we can just move it up. If we decided we wanted it to be some off-centered somehow, we can do that. And all of these cuts happen live in the viewfinder, and when we export this to MakerBot, it'll generate all of that geometry we need for us, so that'll be really handy. Now, if we look at our dimensions here, so this is going to be, along the Y, is about 4 centimeters. And in fact, the only thing I am going to do, just because I like nice round numbers, is I'm just going to scale this out to 4 centimeters exactly. Let's go ahead and make it 1 centimeter tall. And we can apply that scale. Always remember to apply your scale first, because sometimes that can mess with your modifiers as you export things. So this is looking pretty good to me. I'm going to save that again. And now we basically have to get this out of Blender and into Makerware. And the way we do that is with the export menu. And there are many options and many opinions on the best way to do this. I basically decided to just stick with the one that worked once I found it. And for me, that has been wavefront OBJ files, which are not very popular, as far as I can tell on the internet, but they work great for me. I have a little set of presets here that basically set the Y and Z axis to match appropriately what we're actually looking for. It applies our modifiers for us when we export. It's only going to export the objects that we have selected, and it's not going to do any fancy faces or materials or anything because we don't need those. And then lastly, the scale is at 1,000, and that's actually going to match up so that we have a 1-to-1 centimeter to centimeter ratio when we bring this into Makerware. And so let's make a quick folder for this. This is going to be the Adafruit LCD stand and 001.obj. And then I'm just going to save this in that same folder so that we have everything nice and clean. So that was in here, Adafruit, boom. So now we've designed our very first prototype. We've kept it pretty simple. And now we're going to bring it into Makerware and see how it looks. So I have, it says Replicator Dual, and that's roughly what I have. I have a Power Spec, which is sort of Micro Center's brand knockoff of the Makerware Replicator Dual from way back when. I never used two extruders. I actually just raised the left extruder up because it constantly would just drag on whatever I was printing. And how often do you really need to print in two colors simultaneously anyway? So once you export your file from Blender, you're going to add it into MakerBot and confirm that it looks right. So we navigate back to our stand, and here's our OBJ file that we exported. And we can see it comes in with our slot and is really looking pretty good. It's centered, it's oriented the right way. There's not too much we need to change. Let me just confirm that my settings are the standard ones I like to use. And now we're going to export this file from Makerware to a G-code file. And this is going to be what we finally send to the printer. And so this is the step where basically your 3D model is being converted into a series of instructions that your 3D printer will execute in order to print this model from the ground up. So now if we look in our folder where we've been saving all of these things, you're going to see 3 files. I don't know why there's a material file, don't need that. The Blender file, that's our source file that we're using to create the object. Our OBJ file is the 3D model that we export in order to bring it into MakerBot. And then the G-code file is the one that we export from Makerware and then send to the printer itself. So it looks like everything is wired up. Temperature is cold now because I haven't preheated this. And so basically I just upload the G-code file that I just made. And so I'll navigate back to where all of those were. And we want the G-code file. This is what we're sending to the 3D printer. So you say open, and this will upload to the Raspberry Pi that's down by the printer. And this generally takes a second. I think it does a little bit of post-processing to make sure the file is valid before it actually prints it. And it also adds some precursor and postcursor G-code in some instances. So I have a cooling fan that I like to turn on when I'm printing in PLA, and so it modifies it and things like that. But you don't need to worry too much. This should work right out of the box with whatever Octopi starts with. Once it's done, it's usually the first thing to pop up in this menu. Once this is there, you can just hit this print button, and it should start going. It gives you a reasonably inaccurate estimate of how long this print is going to take, but it is a very small object, and it's not too complicated. And we're not printing it at a very high resolution. I think this is 0.2 millimeters, so we're going to let this go and come back and see how well our print turned out and see how we have to modify it from there. So it doesn't happen often, but it does happen sometimes. You will get your first print out of the printer, and it will actually fit. Let's take a closer look here. How close can we get? So here's what we got. This is our wedge that we designed in Blender with our cutout for the feet. And it's not perfect, but it does pretty much slide in. This is just a little snugger than I would want it to be, but it does pretty much work, and it does do a good job of balancing this screen the way I wanted it to. Though I immediately had a couple of thoughts. One of them is when this is on my desk, it's kind of an inconvenient angle. Basically, it would be better if we could sort of have the screen come in like this, and so it's sort of facing upwards from my desk. So I'm going to try and modify it for that, and also just make this cutout a little bit bigger. So let's go back into Blender and make those adjustments. Okay, here we are back in Blender. So we wanted to make a couple of different changes. The first, and the easier of the two, is that this hole was a little bit too snug. And so we were basically just going to scale this up by 2% here. So I hit S and then 1.02. And actually, let's turn off 3D cursor scaling mode as well, so that we scale it from the center. So say, go into edit mode and say scale 1.02. And then that's just a little bit bigger. So now if we hide that again, we'll see that our hole has followed suit. But we also wanted to make it so that our screen would tilt back a little bit in this direction, so that it was kind of a comfortable viewing angle against a desk. So to do that, we're going to move this model as well. So actually save a new version. So in this case, if you hold Control, you'll snap to pretty, you'll snap to basically certain increments of rotation. So we just hit R here and hold Control. We'll be rotating in increments of 5 degrees. And so we don't want to go too far because we don't want it to tip over, but maybe 15 degrees would be a good balance. So if we do that, and then hide our object again, you'll see that now we have a nice angled cutout going into this foot. I'm also just going to move this a little bit forward because our center of gravity is now going to be a little bit different than it was before. And so if we hide this again, now we have a nice slope going in, so we'll be leaning back here and have a little bit of extra footing in the back. We may end up wanting to adjust this again and maybe move this back foot out by a centimeter, something like that. But let's not do it right now because it was working. Yeah, you know what? If it is tilted and we're going to be trying to use a touch screen and so putting kind of a force onto it, then we're almost certainly going to want to extend this. So we can just hit GY and hold Control. Just bring it out 1 more centimeter, and then we have a little bit of extra room in the back. And that's all. So now we're sort of ready for round 2. We can just select our object and export it to an OBJ. And of course, make sure that you're using your MakerBot presets that I've provided. And then we're going to save it as number 2. Then we basically have to go through this process one more time of bringing it into MakerBot and exporting a G-code file that we can send to the printer itself. So in MakerBot, give it a quick once over and make sure that it looks about right. And then we're just going to export a print file. You just click on the 002 and it will append the G-code extension automatically. It's going to slice it nice and quick. Larger models will take a long time here, but because we're really only talking 20 or 30 layers, something like that, it's going to go very quickly indeed. And then we can just upload this newest one to Octoprint and iterate. It's best to make incremental changes. You want to make fairly small updates each round and not try to do too much at once because you're never sure how different things are going to interact or different changes to your model will interact. So in this case, we're just changing the size of the hole to be a little bit bigger, and we're changing the angle of the hole to allow us to have a little bit of a more ergonomic tilt to the screen when it's sitting on the desk. So once everything has been uploaded, you can just hit print. I'll be back in about 17 minutes. So our new one turned out pretty well. We have the extended back, basically. That's going to give us a bit more leverage in the right direction now that we're tilting things. And I think I'm also going to tilt it back by another 5 degrees or so. So it's really pretty good. I just want it a little bit further back. So I can make those 2 adjustments in Blender real quick. And then we'll, I think we're close enough that we can print out a pair of these things and throw them on Thingiverse. So let's go back to Blender. All right, here we are back in Blender. And everything's pretty good except for we do want to increase the size of our cutout a little bit more. It seems to me that it's mostly wrong in the X dimension. I'm going to go in here and I'm just going to scale the X by 1.05. Yeah, 5%. And that's going to scale the, and then I'm going to scale the Y. If you hit Y twice, it will allow you to sort of scale along the original dimension of the object, because now that we have it tilted, if we just scale along the Y here, you'll see that it gets a little bit distorted. Scale YY 1.03. There we go. So now we have a little bit more headroom here, and I'm even going to make this go down just a little bit more into the bowels of our holder here. Now if we hide this, that looks about right. And then the last thing we wanted to do was to adjust the rotation even a little bit more. So another 5 degrees ought to do it. And then we can raise it up so that we cut through our object completely. So if I hide this again, here we go. Hopefully this will be our final design. So we're going to scale this, or sorry, save this as number 3 to then export it using our OBJ presets. And again, we're going to always keep our names in sync so we know what we're talking about, and this is going to be number 3 as well. Back into MakerBot, same deal. Remove our old one, add our new one, round 3. And in fact, I'm at this point pretty confident that this one is going to be the one to watch. So I'm actually just going to hit Apple D to duplicate this, and I'm going to make 2 of them. And the reason that I put them a little bit further apart is so that it gives you a slightly cleaner print if you give each layer a little bit of time to cool. So even though you're adding a little bit of print time, you're going to get a slightly higher quality print by having them be a little bit further away. Those look pretty good to me. Let's export them as G-code and hopefully go for the home stretch. These 2 feet fit more or less perfectly. The angle is pretty good. Maybe needs a little bit more length in the back since it is a touchscreen and it's resistive, so you do need to kind of put a little bit of pressure on it. But I'm pretty happy with it for 3 rounds of revisions. Usually it's going to take a little bit more, but of course this is a pretty simple task. So hopefully that was useful if you're getting started out in 3D printing and 3D design. I don't know if that's the best way to do it, but that's how I do it. So thanks a lot.